Hello everyone. In this video, we'll discuss about the processors, importance in a operating system, and more detailed about the processors in the operating systems. A processor represents an active instance of a computer program encompassing the program's code and its current execution state. It is a vital for an operating system because it facilitates multitasking and optimizes the utilization of system resources. The OS is responsible for managing processes, ensuring that each one receives appropriate CPU time, memory, and other resources. This management enables multiple programs to operate concurrently without conflicts, maintaining system efficiency and stability. Importance of an operating system: resources management, multi-programming, isolation and protection, concurrency and system structure. Processors manage and utilize resources such as CPU time, memory, space, and input-output devices. The operating system allocates these resources to processors and ensure they are used efficiently. So the multi-programming, by managing multiple processes simultaneously, the OS can ensure that the CPU is always busy, improving overall system performance and resource utilization. Isolation and protection. Processors are isolated from each other to prevent them from interfering with each other memory and resources. This protection is crucial for system stability and security. Concurrency. The process enable to the OS to handle multiple tasks concurrently, improving responsiveness and performance. System structure. Processes provide a structured environment where tasks are divided into smaller, manageable units, making it easier to design, implement, and manage complex systems. Basic concept of and structures of a processing memory. A processing memory is organized into several distinct sections. Text segment, code segment contains the executable code of the program. Is read only to prevent the accidental modifications. Data segment contains global and static variables that are initialized before execution, which is divided into two parts: initial data and uninitialized data. Initialized as the variable and the specific initial values, where the uninitialized data has for the variable without explicit initial value. Heap, which is used for dynamic memory allocations. Expands and contract as a program allocates or deallocates memory. Stack memory data such as function parameters, returns address, and local variables. Follows last in first out, which is called as LIFO, and growing and shrinking with the function call and returns. So this is the diagram. So the first thing is the text and initialized data, initialized data and heap, and then stack. So the in the stack side you can see that it is called as a high address, and near the text it is called as a low address. In between, the initialized by 0 by executor, and read from program files by execution. Command line arguments and environment variables are after the stack, which is called as the high address. Program counter, PCI specific register that holds the address of the next instruction by executor. Process control block, which is called as PCB, a data structure used by the OS to manage and control the processes. It contains essential information about the process, which includes the process ID, process state, CPU registers, memory management information, accounting information, and input-output status information. Sections of a process in memory. Command line segment argument. These are the parameters passed to the program at the time it is executed, often used to control the program behavior or to provide input data. Text. This stores the information. Executable code. It is typically read only to prevent accidental modification of the instructions. Data contains global and static variables. It is divided into initialized data for variables with specific initial values, and uninitialized data for variables without explicit initial values. Stack, which is used for the managing local variables and function calls. It grows and shrinks with the function calls and returns, following a last in first out LIFO order. This section holds temporary data such as function parameters, return address, and local variables. Heap, which is nothing but used for the allocation of the dynamic memory in the areas where memory can be allocated and are deallocated as required during the program execution, providing flexibility in the memory usage. program counter. This special register stores the address of the next instruction to be executed, playing a key role in the managing control flow of the program. Register status. This contains the current value of the CPU register, which are used for the different computations while the program runs. This register holds intermediate data instructions and other crucial information needed by the CPU. So in this video we have learned about the different processes and the importance of an operating systems, as well as we have discussed about the sections of the process in the memory. Uh, so in the upcoming video we'll discuss about the operating systems in the way of our program. Thank you so much.